this is the final part for Unit 33 about a special type of polymer called polyester. Now, unlike those polymers we have learned before, for example, polyethylene, polyvinyl chloride, PVC, the polyester actually composed of ester linkage, that is COO. So you should familiar about it. And in order to produce such polymer, we need special type of monomers. The one should contain dicarboxylic acid group, that is a molecule contain 2 COOH, and a diol, that is a molecule contain 2 hydroxyl group. Take this as example. After they combine together to form an ester, or you can say is esterification, we form polyester. Take PET as an example. Now, the structure of PET, don't worry, no need to memorize. For one monomer for each of them, the chemical equation. Now it's your turn to write down the chemical equation. You can pause the video until you finish your job. And here is. So you can see an ester is formed, and don't forget to mention the water comes out. So what about when there are n monomers? So what will be the result? Times n. The result will be a long polymer chain like this. So you can see, besides the ester group we have come across, a new ester group is formed here, and the number of water formed will be 2n minus 1. Now this is the formation of a polymer chain. So you can see the criteria of monomer in this type of polymerization. We need a monomer with 2 functional groups at the same time. One is on the front and one is on the back. And during the process, water molecule is removed. So this type of polymerization is called condensation polymerization, and the polymer formed is called condensation polymer. As a comparison, you can find that the polymer formed will be slightly lighter than the sum of raw materials, because small molecule, for example water molecule, will be eliminated during the process. So the polymer we obtained finally will be lighter than the raw materials. So as we mentioned before, you no need to memorize the structure of PET. But if you are given the structures, it is easy for us to understand, because there are highly electronegative element, oxygen here. So the polymer chain of PET will be polar, and this will increase the intermolecular force and hence increase the strength of the polymer. However, with the ester functional group, that means the polymer can undergo alkaline or acidic hydrolysis, or we can say such polymer cannot be used in those highly acidic or highly alkaline conditions. And here are the common example for the polyester. Compare with those traditional fibers, for example from cotton, the polyester product will be less able to absorb moisture, but it has a better resistance from the attack of the insects. And here are the checkpoints. So again, please stop the video and wait until you finish the checkpoint. Here are the answers. You are given a polyester A come from compound X and compound Y. So have a look. Compound X is a dicarboxylic acid and compound Y is a diol. So you expect at the end they will form polyester as mentioned in the questions. So question 1, is X contain carbonyl group? Well, the answer is no. Carbonyl group, right, don't mix up. Carbonyl group refers to CO double bond only, while this one is correct. C, polyester is an addition polymer. Well, to answer these questions, please remind that in case for addition polymer, their monomer should contain CC double bond, but obviously XY don't have one, so C not correct. Finally, is there any hydrogen bond between polymer chain of A? Well, polymer A is an ester, so of course we don't have any hydrogen bond, so the answer is boy. Question 2, compound Y made from dichloroethane. Well, that means you are requested to change from chloro compound to hydroxyl compound. So which of the following chemical can help you? Easy. It is sodium hydroxide solution for sure. And then, what about the chemical equation for making polymer A? Because you are going to make a polymer, so you should start with N monomer X and N monomer Y. So let's do it. Here are the reactant side. So what about the product side? First, you can see I try to use different colors to illustrate the carboxylic acid and the alcohol part. Don't forget to mention the green word N here. And the second thing you should not forget is the water formation. And finally, is it a thermoplastic or not? Alright, so have a quick revision. What is meant by thermoplastic? It means the polymer will become softened when you heat it. So how can I know that? The answer is easy, because there is no covalent bond between polymer chains. So let's see how to interpret in terms of structures and intermolecular force. And here shows it is a thermoplastic for sure, because there are no covalent bond between the polymer chains. So this is the polymer's structure. As a result, you can see only weak van der Waals force is formed between the polymer chains. While you heat it, the polymer will become more mobile and hence it can be softened. So here comes the final part in Unit 33. In last section, we have come across we can use carboxylic acid and diol to form a polyester. So if it works, so can we do the same job, but this time we use dicarboxylic acid again, but instead of making ester, this time we use amine, and you can predict the result. The carboxylic acid will contribute the hydroxyl group, while the amine will contribute an hydrogen. The results will be a polyamide. Here shows this is a polyamide. So again, I use two different colors to illustrate how monomer allocate. And again, don't forget the water like this. So the result is a polyamide, or simply we give them a brand name called nylon. In order to form a polymer, they should have dicarboxylic acid and diamine. So at this point, maybe you can find the characteristic of the monomers between addition polymer and condensation polymer. So let's make a new page for this. For addition polymer, their monomer must contain a CC double bond. But the condensation polymer, their monomers must contain two functional groups. Sometimes we call them bifunctional group. Otherwise, they cannot connect each other. The second one is for condensation polymer. During the polymerization, small molecules will be eliminated from the polymer chain. As I mentioned before, that means the polymer you obtain will be slightly lighter than the sum of the raw materials. But for addition polymerization, nothing will be eliminated during the process. In this video, you will see how the nylon is made in the laboratory. So we will have a lab section in the coming week to demonstrate this to you. And here shows. Again, please stop the video and complete writing the equations. First, what about when there are only one monomer of each type? So what will be the result? Please write down the chemical equation and what the situation will be when you get n monomers. Here shows the hydrogen from amine and the OH from the carboxylic acid will combine to form a water molecule, and two monomer now connects. To simplify the case, I draw the NH and CO double bond here to let you understand how the bonding is formed. It doesn't matter whether which one is pointing upward and which one is pointing downward, it's okay. Next, what about when there are n monomers? First, we add the n here and then it becomes a polymer. And don't forget the water form like this. And we finish. Now, for the nylon, there is a special naming system. First one, we will count how many carbon atoms in the diamine. For example, in case you got 6 atoms in the diamine, then we will label the first one as 6. The second one is the dicarboxylic acid. When there are 6 carbons in the molecule, now here please pay attention. And the middle there are 4, and then the 5 and the 6th one. All together there is 6 carbons in the dicarboxylic acid. So we label another 6 in the name. So if nylon is formed between these two monomers, we call them nylon 6,6. So with this idea, what is meant by nylon 610? Well, easy. The first 6 represent there are 6 carbons in the diamine, while the 10 means there are 10 carbon atoms in the dicarboxylic acid. Yes, so we will get our answer. The first one, we got 6 carbons in the diamine group, and then followed by 10 carbons. Now pay attention, because we have 2 carbons in the front and the back of the monomer, so only a CH2 here. So some students may find that or may misunderstand that there are 10 CH2 in the molecule. This is not correct. Unlike the polyester, for nylon, because there are hydrogen bonds between the nylon molecules, so we can expect that there are strong intermolecular force or hydrogen bond between the nylon molecules, make that become greater strength compared with polyester. However, nylon is not corrosion resistant at all, because the amine group also can under alkaline or acidic hydrolysis during the process, so they can be hydrolyzed easily. As a result, they are not supposed to be used in the environment with strongly acidic or strongly base, just like the case of polyester. When you drop it with nylon, yes, a hole will form and your components or your nylon object will be damaged. So please finish this part and we will check the answer on next lessons.